Hello everyone, today we're going to look at how to solve equations with trig identities. So let's look at example 1. We have 2 cos squared theta minus cos theta minus 1 equals 0. This might look very complicated, but let's see if we replace cos theta with x. So we have 2x squared minus x minus 1 equals 0. So this looks a lot easier, so we can solve by this. So factorize first. So I have 2x and x. Then I have plus 1 and minus 1 equals 0. So I have just factorized my equation. Then I have, then what I need to do here now is replace the x with my cos theta. So I have 2 cos theta plus 1 cos theta minus 1 equals 0. So just like how you would solve a how you'd solve a quadratic equation. So you set each bracket to 0. So my first values are 2 cos theta plus 1 equals 0, or cos theta minus 1 equals 0. So just solve your equation. So 2 cos theta is equals to minus 1. So cos theta is equals to minus a half. Or cos theta is equals to 1. So I have my two solutions here. So now I need to find out my principal values. So my theta is going to be equals to 120, or theta is going to equals to 0. Then I'm going to sketch my graph. So you need to find the values between 0 and 360. So the question is, find the values between 0 and 360. So let's sketch my curve. So my cos is going to look something like this. So 0, 1, minus 1, 90, 270, and 360. So let's look at my first value is minus a half. So minus a half is going to be this line here. So I'm interested in those 2 points here. So this is 120. And therefore our symmetric properties, so this part here, we have moved by 120. Therefore from 360, we also need to subtract 120. So 360 minus 120 is going to equals to 240. So we know our two values here are 120 and 240. Then looking at our 0, so when cos is equals to 1, it could be 0 or 360. So I have my 4 solutions. So theta could either be 0, 120, 240 or 360. So let's look at my example 2. I have sin squared theta minus 30 degrees. So step 1, what I'm going to do is just to solve and find my key values. So I have squared, so I need to square root both sides. So square root, I become sin theta minus 30. So square root 1 over 2. Remember, when you square root a number, you get two solutions, plus and a minus. Then you take your sine, so your theta minus 30 is going to equals to sine minus 1. So you get two solutions, which is, so you get plus 1 over root 2 or minus 1 over root 2. So let's take your first value. So look at 1 over root 2. Your solutions, so your principal value will be sine minus 1. Which is 45 degrees. Then you look at your principal value for sine minus 1 minus 1 root 2. Which is minus 45 degrees. So let's sketch our sine curve to have a look. So this is when theta minus 30 degrees. So let's do a sketch of our sine curve. This 0 minus 1. So my first value is that when it's equals to 1 over root 2, which is 45 degrees. So 1 over root 2 is approximately 0.7. So I'm going to say here is my values for 0.7. So let's say this is when this value here 0.7. So I have my solutions, which are 45. Then again, it's symmetrical. So this point is 180. So we need to do 180 minus 45, which is 135. Then I'm going to look at my second. So this is when it's approximately minus 0.7. So I'm interested at those points here. So this first one is minus 45. We're not interested in this because it's not in our range. But we do know that it repeats every 360. So we know this value here. So minus 45 plus 360, which is 315. Then we can find out this value here because it's symmetrical. So from here to here, we got to minus 45. So from 180 to here, we need to do plus 45. So 180 plus 45 is 225. So this point here is 2 to 5. So remember, it's symmetrical. So this distance here is equals to this distance here. So we have our theta. So we have our 4 values. So now we want to find out the values for theta. So we just need to add 30 to each of those. So 45 add 30 is 75. 135 add 30 is 165. 225 add 30 is 255. And 315 add 30 is 345. So that's all my solutions. Now let's look at example 3. So I have 2 cos squared x plus 9 sin x equals 3 sin squared x, and we want to find the range between minus 180 and positive 180. So we need to use the trig identities we have learned earlier. So the first one is that cos squared x plus sin squared x, it's the same as 1, and that, so we're going to use this to help us to solve the equation. So we need to change this cos into sine. So we know that rearrange, so cos squared x is the same as 1 minus sin squared x. So let's replace this into our equation. So I have 2 bracket 1 minus. So what we're doing here is we're replacing cos squared x with 1 minus sin x. Because to solve an equation, we need to have all the same functions. So we need to, they all need to be written in terms of sine to solve a quadratic equation in sin x. So we have minus sin squared x plus 9 sin x. So expand our bracket. I have 2 minus 2 sin squared x plus 9 sin x equals 3 sin squared x. So what I can do here is replacing my sin x is just going to equals to x. So it looks like a quadratic equation. So I have 2 minus 2x squared plus 9x equals 3x squared. So just rearrange to, remember when we solve, we need to make our quadratic equation equals to 0. So just rearrange our equation. I have, move to the other side, I have 5x squared minus 9x minus 2 is equals to 0. Then I can factorize into 5x and x plus 1 and minus 2 equals 0. So I have just factorized my equation. Now I can substitute back my x values. So x is same as sin x. So you don't need to do this step, but I find it easy to factorize my equations by placing by x. So if you can see it straight away, you don't actually need to replace your x, your sin x with x, but I found if you do this, it looks easier to factorize. Then it's sin x minus 2. Again, set each bracket equals to 0 and find your principal values. So you have 5 sin x plus 1 equals 0, or sin x minus 2 equals 0. So you have sin x 5 sin x equals minus 1. So your 5x. So your sin x is equals to minus 1 over 5. Or your sin x is equals to 2. Well, as we remember, what our sin looks like, it must be between 1 and minus 1. So this is not the right, so this is impossible. So we could only work with sin x equals minus 1 over 5. Type into your calculator, you get your principal value, which is minus 11.5 to 3 SF. So let's do a quick sketch of our sine curve. So this is 0. So we have sin x is equals to minus 1 over 5. So this is approximately here, let's say. And we know that it repeats every 360 degrees. But this question, we're actually interested in the negative part. So let's just sketch our graph a little bit further. So let's just sketch our graph again. So we're interested in the interval minus 180 to 180. So this is 0, this is 180. So this is part of the graph we are interested in, minus 180. And the maximum is 1 and the minimum is minus 1. So sin x can never be equals to 2, so that's not the correct solution. Then we look at, we're interested in sin x is equals to minus 1 over 5. So minus 1 over 5 is approximately here. So we know this first value here is minus 11.5. Just expand our graph a little bit. So we're going from 0 to this direction, 11.5. Again, the symmetrical property. So therefore, we need to add 11.5 to minus 180. So we know our solution is equals to 168.5. So we have two solutions for x. So x could either be equals to minus 11.5 or minus